Hi, this is EC. Hi, this is ECE109 Introduction to Electrical Engineering, Lecture Note 2. In this section, we're gonna focus on voltage and current sources. Basically, the outline, what is voltage, how we can define the independent voltage and current sources. Then we talk about the ideal dependent sources, current or voltage again. Then give you some examples. So voltage is the energy required to move a unit charge through the element. We measure as a volts. The voltage VAB between 2 points A and B in electric circuit is the energy need to move a unit charge from A to B. That's why we can represent the voltage AB equal dW over dQ, which is we mentioned this one in previous lecture note. In this case, W is the energy measured as a joules, then Q is the charge measured as a coulombs. So basically 1 volts is equal 1 joules over coulombs. So this is the voltage VAB plus sign minus sign at terminals. Okay, so in this section we're gonna show how we can represent the independent voltage and current sources. The ideal independent sources is an active element that provides a specific voltage and current that is completely independent of other circuit element, which means if you connect anything over the here as an element will not gonna change the voltage value. Of course, because of the voltage source here, the current will change depends on the element value, but not the voltage. Similar stuff in this case here, when you connect the element to the independent current sources, the current value will not gonna change, but the voltage over the here VAB may change. Okay, the independent voltage source we show as this form or in this form for DC. We actually alternative way we show as sine form like this. Independent current source we show is a one arrow pretty much. Um, DC voltage sources can be connected in serial, so we can combine them, find the equivalent voltage sources easily. In this one, we have 1.5 volts minus plus here, another 1.5 volts minus plus. When you connect them together, it's gonna be 3 volts right there. The rotation is important, negative, positive. We have to be careful about that one. Okay. Same way, the current sources can be connected in parallel, then can be combined a single equivalent the current source here. In this case, we have I1 is 5 milliampere, we have I2 10 milliampere. They are both going same direction, so if you're gonna find the I will be equal I1 plus I2. That's why 5 plus 10 give you 15 milliampere. um, in here in example, uh, this example, we need to bring this circuit here. Basically, combine the voltage source as much as we can combine, and we're gonna combine also currencies if we can combine without affecting the total circuit there. So when we look at here, voltage source, we have one voltage source right there, another voltage source. They are serial, and minus plus right there, minus plus. That's why we can combine them as a 40 volts. If notation is different, we may need to subtract them. We have to be careful too also. When we look at the current sources, we have one current source right there. We have another current source right there. They are parallel. Even there is a resistor between there because they are connected each other, so we can combine them together. In this case, 5 milliampere plus 2 milliampere, it will be 7 milliampere. After they combine them, if we draw the circuit, redraw the circuit again, we're gonna have 5 of 40 volts. 40 volts right there. We have 3K and 5K right there. When we combine them, this will be here 7 milliampere, 2K and 4K. Resistors still parallel right there. We didn't combine them resistor values. yet. Okay, there are also some dependent sources too also. So we're gonna give you the ideal dependent sources here. The ideal dependent sources is an active elements in which the source quantity is controlled by another or voltage or current. In this case, when you look at this one here, this is voltage source, we know it. And we see the controlling by another voltage here, VC. The KV is here, basically that's constant coefficient. That's why we call this one voltage control voltage sources right there. So voltage between right there, VAB, will be equal KV times VC basically. In this way, you can see this is a current source, dependent current source, but the controlling by the voltage VC here. That's why voltage control current sources. In this case, the current right there, I, will be equal the coefficients times the VC voltage. Two more, which this case here, we have a voltage source, but when you see controlling by the current, that's why current control voltage source. Rm is again coefficients right there. So the plus minus right there, the voltage right there will be equal Rm times the IC current. In this case, this is current source and controlling by another current right there. That's why we call current control current sources. So if you're gonna find the I, in this case, Ki times, which is coefficients, times IC. Okay, let's give example. In this example, we're going to calculate the power supplied or observed by each element. We'll look at this way here first. There are some voltage, current values are given to you. I look at here, this is 5 amperes right there, and this is 12 volts. It's entering the positive side. I can find how much power we spent on the P2. So it's gonna be 12 times 5. That will give you a 60 watts right there. Okay. If you say I want to find the how much power supplied right there, I call supplies because entering the negative side, which is entering 5 ampere times 20, 100 negative watts right there. This is supplied. This element P2 is observed. If I want to find the P3, I know the current, I know the voltage entering the positive side. That's why 8 times 6 give you 48 watts of energy observed here. If you say I want to find out how much power this supply here, the current right there is I will be equal 0.2 I. I will call I2 here. Okay. So 0.2 times I is right there controlling by current 5. That will be equal 1 ampere. Okay. So basically I can find a 1 ampere and I know the voltage 8 plus here 8 volts entering the negative side here. That's why this case 1 times 8 is 8 watts is supply here. So it's same equation we have here. When you find the total power here, you will see observed power will be equal the supplied power, which that's why it's equal 0 in this case here. In the future, when we try to solve the problems, the basic idea, try to define the problem, understand the problem first, what is given, what is asking, then present everything you know about the problems, then try to establish alternative solutions and which one is better or which one is give you a quick or easy answer. That's why you can focus on it. Then attempt to solve the solution. Then after the solution, make sure you evaluate the solution, check the accuracy, does make sense. Sometimes if it doesn't make sense, you may need to go back to redo again. So also you have to make sure that is this solution satisfactory for you. Okay, these are just basic idea in this section. We will see in the next section.